Welcome to ViewChem, the Chemistry Animations channel. Representation of organic molecules. In this animation video, different ways of representation of organic molecules are presented, with few examples. Molecular formula: it is a chemical formula of a compound that shows the kind and number of atoms involved in the formation of that compound. Examples: molecular formula of methane is CH4. This indicates that methane molecule comprises of 1 carbon atom and 4 hydrogen atoms. Molecular formula of ethane is C2H6, and that of ethyl alcohol is C2H6O, and acetaldehyde is C2H4O. Structural formula: it is written by inserting all the bonds, that is, short lines, that connect the atoms. Single line indicates single bond, while 2 and 3 lines indicate double and triple bonds respectively. It is an expanded version of condensed structural formula that shows the linkages between the atoms. Examples: in methane, carbon atom is bonded to 4 hydrogen atoms through 4 single bonds. In ethane, there is a triple bond between 2 carbon atoms, and each carbon atom is bonded to a hydrogen through a single bond. Condensed structural formula: it is written as a line by omitting all the bonds between the atoms. It is a textual representation. It is an expanded molecular formula and condensed form of structural formula. Examples: condensed structural formula of methane is CH4. Ethane is CH3CH3. Ethyl alcohol is CH3CH2OH, and acetaldehyde is CH3CHO. Line angle formula: it is the skeletal structure of the molecule. It is also called as shorthand formula. In this representation, the covalent bonds are shown as lines. All the atoms, other than carbon and hydrogen, are shown. Hydrogen atoms are shown only when they are bonded to any atom other than carbon. Carbon is supposed to be present at the corners and at the ends of the lines. Sufficient number of hydrogens are deemed to be bonded to each carbon to fulfill the tetravalency of carbon. Examples: ethane. In the line angle formula, ethane is represented as a line. It should be understood that, at both the ends of the line, methyl groups are present. Ethyl alcohol. It should be understood that, at the left-hand side end of the structure, methyl group is present. At the angle, CH2 group is present. Hydrogen atom is shown only when it is bonded to any atom other than carbon. Acetaldehyde should be viewed as zigzag structure is another way of representation of a molecule, which is also called as not a projection. This is also a type of line angle representation. In this type of projection, the molecule is represented in W shape. The tetrahedral carbon backbone is supposed in the plane of the paper, and the substituents projecting towards the viewer are shown in solid wedges, while the substituents projecting backwards are shown in dashed wedges. Lewis structure: it is a form of structural formula, in which the lone pairs of electrons present on the atoms are shown. For example, in the molecule shown here, we can observe 2 lone pairs of electrons on oxygen, 1 lone pair of electrons on nitrogen, and 3 lone pairs of electrons on chlorine. Lewis dot structure: in this type of representation, a chemical bond is represented by a pair of electrons. Double bond with 4 electrons and triple bond with 6 electrons will be shown. Ball and stick model: it is a type of three-dimensional representation of a molecule. In this model, atoms are shown as colored spheres, in accordance with CPK system, that is, Corey, Pauling, and Coltoun system, while the bonds are shown as sticks. As an example, methane is shown. In the ball and stick model of representation of methane, black color ball represents carbon, and white color balls indicate hydrogens, as per CPK system. Double and triple bonds are represented with curved sticks. Ethene, containing a double bond. Ethine, containing a triple bond. Framework model: it is also called as Dryden model. Earlier, in the original model, stainless steel material was used. Later, it was replaced by plastic material. In this model, atoms are shown with solid and hollow spikes. These spikes represent valencies of the atoms. A bond is formed by clicking the solid rod into the tube. In the modified version, atoms are represented, along with their orbitals, according to their valencies and hybridization. The orbitals are shown as spikes. The spikes are made up of alloys. sp3 hybridized carbon. 4 sp3 hybrid orbitals. sp2 hybridized carbon. 3 sp2 hybrid orbitals. And 1 unhybridized p orbital, sp hybridized carbon. 2 sp hybrid orbitals. And 2 unhybridized p orbitals. The bonds are represented with plastic tubes, which can be inserted into the spikes that represent the orbitals. This model can also be called as skeletal model. Tetrahedral carbon. 4 hydrogen atoms. Methane molecule. Another tetrahedral carbon. Ethane molecule. Another way of showing methane molecule, in the framework model. Space-filling model. It is another way of three-dimensional representation of molecules. In this model, a molecule is represented as fused, colored spheres. Specific color indicates particular atom. In accordance with CPK system, the radii of the atoms would be proportional to the radii of the spheres. Carbon, with black color sphere, and hydrogens, with white color spheres, are represented. Fischer projection formula. Emil Fischer has developed this formula. It is a way of two-dimensional representation of three-dimensional molecule. Perspective formula. It is the three-dimensional representation of structural formula of a molecule. CX and CY bonds are in the plane of the paper. Dashed wedge, CB bond, indicates that the substituent is away from the viewer, that is, below the plane of the paper. While the solid wedge, CA bond, represents that the substituent is towards the viewer, that is, above the plane of the paper. If we look from this angle, the molecule appears as X and Y are away from the viewer, while A and B are towards the viewer. Fischer projection. Example, lactic acid, that is, 2-hydroxy-propanoic acid. If we look from this angle, the molecule appears as Different steps involved in writing Fischer projection from perspective formula are shown below. Another interesting example: 2,4-dihydroxy-3-chloro-butanol. C1 is placed at the top in the vertical line. The topmost and the bottommost groups of atoms are visualized away from the observer, dashed wedges, while the groups bonded to the middle carbon atoms are visualized towards the viewer, solid wedges. Carbon chain is represented with vertical line, and the atoms, or groups of atoms, bonded to the middle carbons, with the horizontal lines. Conformational analysis. Different spatial arrangements of atoms in a molecule, which are obtained by the rotation of carbon-carbon single bond, are called conformations. Molecules exhibiting different conformations are called conformational isomers, or conformers. Because of rapid interconversions, conformational isomers cannot be isolated. Conformational isomers can be represented either by Sawhorse projection formulae or Newman projection formulae. In the Sawhorse projection, carbon-carbon bond is viewed from an oblique angle. That is, a diagonal line represents the bond between two carbon atoms. It should be understood that the carbon atom, which is present at the left-hand side, is nearer to the viewer, while the carbon atom, on the right-hand side, is away from the viewer. Atoms, or groups attached to the carbon atoms, should be drawn at an angle of 120 degrees. Now, let us visualize the dihedral angle in different conformations of a molecule in sawhorse projection formulae. R1, front carbon atom, and rear carbon atom, are in one plane, X-plane. Front carbon atom, rear carbon atom, and R5, are in another plane, Y-plane. The interior angle, subtended between X and Y planes is dihedral angle, and, in this example, it is 60 degrees. The conformation, in which the dihedral angle between front CH bond and rear CH bond is 60 degrees, is called staggered conformation. In the staggered conformation, there will be maximum distance between R1 and R6. It is the most stable conformation of all other possible conformations, because of least repulsions between the electron pairs of CH bonds of adjacent carbon atoms. Now, let us understand another important conformation, the Eclipse Conformation. R1, R2, and R3 are shown as red color balls, while R4, R5, and R6 are shown as blue color balls. In the staggered conformation, if the front carbon, along with its substituents, rotates by 60 degrees, the result is the formation of eclipse conformation. The dihedral angle in eclipsed conformation is 0 degrees. In the eclipsed conformation, there will be minimum distance between the front CH bond and rear CH bond. It is the most unstable conformation of all other possible conformations, because of maximum repulsions between the electron pairs of CH bonds of adjacent carbon atoms. Any other conformation between staggered and eclipsed is called Gauche Confirmation. The dihedral angle of Gauche conformations will be more than 0 degrees and less than 60 degrees. Now, let us observe few Gauche conformations. Rotation of front carbon atom, with its substituents, by 10 degrees, in the clockwise direction, gives a Gauche conformation. In this manner, rotations of front carbon atom, with its substituents, by 10 degrees each time, in the clockwise direction, give few Gauche conformations. Rotation, by another 10 degrees, gives eclipse conformation. Newman projection formulae are a type of representation of conformational isomers. In Newman projection formula, the molecule is viewed through CC bond. The front carbon atom is the proximal carbon atom, and is represented by a dot, while the rear carbon atom is the distal carbon atom, and is represented by a circle. Three lines, coming out from each carbon atom, at an angle of 120 degrees, represent three bonds. A molecule, in the Newman projection formula, can be viewed as Now, we are observing the staggered conformation of a molecule. The dihedral angle is 60 degrees. In Newman projection formulae also, in the staggered conformation, there will be maximum distance between the front CH bond and rear CH bond. It is the most stable conformation of all other possible conformations, because of least repulsions between the electron pairs of CH bonds of adjacent carbon atoms. The rotation of the front carbon atom by 60 degrees yields eclipse conformation. The dihedral angle in eclipsed conformation is 0 degrees. In the eclipsed conformation, there will be minimum distance between the front CH bond and rear CH bond. It is the most unstable conformation of all other possible conformations, because of maximum repulsions between the electron pairs of CH bonds of adjacent carbon atoms. The rotation of front carbon atom by another 60 degrees results in the formation of staggered conformation. Any other conformation between staggered and eclipsed is called Gauche conformation. The dihedral angle of Gauche conformations will be more than 0 degrees and less than 60 degrees. Now, let us observe few Gauche conformations. Rotation of front carbon atom by 20 degrees gives a Gauche conformation. Rotation of front carbon atom by another 20 degrees gives one more Gauche conformation. Further rotation of front carbon atom by another 20 degrees gives eclipse conformation. Let us have a quick look of different conformations in Sawhorse and Newman projection formulae. Staggered, eclipsed, Gauche. Different ways of representation of organic molecules. Structural formula, condensed structural formula, line angle formula, zigzag formula, Lewis structure, Lewis dot structure, ball and stick model, framework model, space filling model, perspective structure, Fischer projection, Sawhorse projection, Newman projection. Thanks for watching. Please like, subscribe and share.